Hey folks, this Tall Tower Challenge video guide is designed to supplement the Tall Tower Challenge written guide, which provides all project details that include a summary, key vocabulary, materials required, procedure with accompanying design criteria, activity extensions for students who need more, activity scaling to differentiate instruction. The written and video project guides assume an audience of non-engineers, so I am hopefully talking to you in a very straightforward manner and hopefully explaining it well when I don't. The Tall Tower Challenge activity explores the design of tall structures, skyscrapers and towers, etc. Students work in teams of 3 to 4 to engineer the tallest tower they can build using straws, pipe cleaners, and paper clips, and nothing else. The tower must be strong enough to support the weight of a golf ball for 2 minutes. Our approach here is based on tryengineering.com's Tall Tower Challenge, and there's a link included to their lesson plan in our project plan. Now there's only one vocabulary term here, and it is tower. And a tower is just a tall building. It's probably self-explanatory, but I decided to put that in there. A note though, I want you to consider incorporating photographs of some of the world's tallest towers in your initial presentation of this project. And I include a link in the project plan to Abu Dhabi's Burj Khalifa Tower website. Not only do they have nice pictures of the Burj Khalifa Tower, they also pay tribute to some of the world's tallest towers, and those pictures that they have are fabulous and will serve as an inspiration to the students. Our materials list is pretty straightforward here. Now we've got 50 drinking straws like these, we've got 50 pipe cleaners, we've got 25 paper clips, and 1 golf ball. I didn't bore you with visuals of those. You know what they look like. Here's our procedure. Now, the first thing you may want to do is review tryengineering.com's lesson plan, again, which is linked via our project plan. Pay special attention to the student worksheets on pages 5 through 7. These worksheets can be provided to students directly to help them document and evaluate their designs, which is always a key part of any of these projects, to document their design so that they're able to make adjustments and tweaks and so forth. Second thing to consider is perhaps using Abu Dhabi's Burj Khalifa Tower website to design and deliver a visual presentation on the great towers of the world, as mentioned previously, and the structural engineering challenges that must be met to build them. This project may lend itself to a little more presentation on the front end because towers are so visual and beautiful. Next, challenge the students to create the tallest tower using only the materials provided: 50 straws, 50 pipe cleaners, 25 paper clips. That's a very short materials list that can support a golf ball for at least 2 minutes. Now, here are a few stipulations. Students don't have to use all the materials. They don't need to use the pipe cleaners. They don't have to use the paper clips. They may need to, they don't have to. The other thing is the golf ball has to be supported near the top of the tower. This is the top of the tower. Golf ball's got to be somewhere towards the top. Here's a numeric stipulation. The bottom of the golf ball can be no more than 20% below the upper height of the tower. What did I just say? If the tower is 5 feet tall, the ball can be no lower than 4 feet from the ground or 1 foot from the top of the tower, because 1 foot is about 20% of 5 feet. And then lastly, students are not provided any other resources. No tape, no scissors. Now you may want to provide some visual design hints based on these photos that I'm about to show. Now, the first photo, and I hope you can make this out here, those are 2 paper clips arranged as a 3-point connector in order to exploit triangles and pyramids into the structure of these towers. That may be helpful to them. And tricky thing about some projects is, well, they're open-ended and there are no real right answers, and you don't want to tell a student too much, but you also don't want to tell them nothing, because there's no starting point to get them momentum towards a solution. The second picture I want to show you is a triangle made out of 2 flexible drinking straws. Consider using the flexible drinking straws here, that may be helpful. And 2 paper clips, 2 flexible drinking straws, 2 paper clips bent into a triangle. Now that particular design does not think about that next step of how do you join that with 2 other triangles to make like this little pyramid thing, but either way, just show that to them. That may help. And then finally, here's a photo of same style of triangle made with 2 flexible drinking straws and 2 pipe cleaners. Now the word to the wise is the students have to budget their materials, so as they experiment and tinker with these different approaches, they have to stay mindful of, well, how many straws and paper clips am I using, how many do I have left, and what size tower is that going to allow me to build. I may have to reverse field, pivot, and come up with something new. That's all part of design. Now, how do we extend this activity? We extend this one like we extend most of them that are of the challenge variety. You can have students reflect on the project by documenting the engineering design process in their project notebooks. That process, again, includes defining the problem, brainstorming ideas in multiple designs, selecting the most promising design, communicating that design, creating and testing that design, and then evaluating and revising the design. Another extension, have students create visual presentations of the world's tallest buildings using photos that they curate, not the ones that you come up with. Have them find others, or have them curate a YouTube playlist of high quality tall building videos. Both of those would be cool. How might you scale this activity? Older students can be required to have their tower support the golf ball for more than 2 minutes. That's fair. Or they can be given fewer materials. That too is fair. Younger students, they can be required to have their tower support the golf ball for less than 2 minutes. You can consider giving them more materials, or you can ignore that 20% requirement. You just let them hang the golf ball wherever they would like to hang it. That's fair. That's pretty much all there is to this one now. It's a straightforward assignment, but I would say the challenge in straightforward assignments with few materials is there's not a lot of direction for what will make an excellent solution. This one's going to test the student's grasp, commitment to, and respect of the engineering design process. But as always, enjoy yourself. This is a nice one. Take care.